Yeah, students, welcome to my class. Now, in today's class, we'll continue the previous session. There is a modular exponentiation. Yes, let me recall once. What do you mean by modular exponentiation? It is an exponential performed over a modulus. So, why we need to do this? Because it is very much useful in computer science, especially in cryptography, where in the cryptography to find in the field of public key cryptography, where it is used in both Diffie-Hellman keys exchange and RSA public and private keys. So for your syllabus, especially CS engineering students, in the next you have RSA algorithm also, how to find the public and private keys. So for that purpose, one must meticulously know the modular exponentiation. So modular exponentiation is what? Exponentiation is the reminder. We'll get a reminder when an integer b, that is a base, is raised to some power e, that is an exponent, and it is divided by some positive integer m, that is called as modulus. So it can be performed with a negative exponent e also by finding the modular multiplicative inverse. Yes, you can perform for that also. So it is efficient, that is a modular exponentiation is efficient to compute even for larger integer. So in today's class we are going to discuss, we are going to study how do you compute the modular exponentiation for very large integers, that is the exponents with big powers. So let us check how to simplify such examples in today's class. So let us start with an example. Firstly, we will take solve 88 raised to 7 mod 187. Yes, why I said this is a larger? Because 88 is a two-digit number, bigger number. When you multiply this of 7 times, yes, this will exceed in your calculator. Yes. So such big number, how you simplify? You have to divide it by 187. In previous class, we did some examples such simple, but they were simple. And when you might have observed difference between this and this number in the previous examples, it was close. Yes, it was close. We can easily simplify by taking the power 1. Now, to simplify such big example, big number, to solve such big number, you I will tell you one simple logic. The logic is what? The logic is, first you have to consider the base, whatever base you have with power 1. For in this example you have 88. First consider with power 1. Later on, go on doubling this. What do you mean by doubling? It's 1, then you have to perform 2. Double of 2 is 4. Double of 4 is 16, 32, like this. Yes, you have to perform like this. You have to double 2 to the 4, 4, 4, 16, 16, 32. So go on doubling if you have such big numbers here, and at which you have to stop at certain point. As you shouldn't go up to infinite terms. Yes, we want some terms that at that point you have to stop. So now here I want 7. So you have to stop to 7. So you might have not get you may not have get that exactly the same power, but you have to add the powers to get the asked power whatever you have. Yes, for such for example, for this one you have a power as 7. Now you will not get, when you double this you will not get 7. Yes, but you can make 7 by taking power 1, power 2 and power 4. Yes or no? Isn't it? Here 1 plus 2 plus 4 is 7. So now you can add the power of this 88, 82, and you can add the powers. So bases are same. So means what? For this example, we need to find 88 raised to 1, 88 raised to 2 mod 187, 88 raised to 4 mod 187. Then you can find 88 raised to 7. This is the simple logic behind to solve such examples. Yes. Now let us solve this example. Yes. Okay. As I said, firstly we need to write the given example with base 1. Okay. So consider here, what is this? 88 mod 187. What will be the remainder? Since 88 is smaller than 187, the remainder is 88 only. Right? Now, next is 88 square mod 187. So, 88 square mod 187 can be written as 88 into 88 mod 187. So, now, what will you get? 88 into 88, you will get it as 7744 mod 187. So when you divide 7744 by 187, you are going to get 77 as the remainder. How you have to check? Check this by your simple division. Divide 774 by 187. I am not going to do this. You have to do this and check whether you will get 77 or not. Yes. After getting this, now you have to double this. 88 raised to 4 now. 4 mod 187, then you can write it as 88 square into 88 square mod 187. Yes. Now, for 88 square, what we have got? We have got remainder as 77. Now, you can write it as 77 into 77 mod 187. But what is 77 into 77? 77 into 77 is 5929. Right? Mod 187. Again, divide 5929 by mod 187. Sorry, 187. Then you will get remainder as 132. Again, check this. Divide 5989 by 187. So now, we need to stop here. Why? Because next is 88 raised to double this. So when you double this, you will get 88 raised to 16. Yes. Multiply with 4, 8, 16 like this. Yes. We need to multiply. We have to, here I missed 8 also. Yes. Now we'll stop here because we want only 88 raised to 7. 88 raised to 7, it can be written as 88 raised to 4, as I said before, 88 raised to 2 into 88 raised to 1. Yes, what is this? This mod 187. I am writing this in place of 88 raised to 7. Yes, but 88 raised to 4 mod 187. What is the remainder? Remainder is 132 into 88 square. 88 square mod 187. What is the remainder? Remainder is 77. Yes. 88 raised to 1. Remainder is 88. 88 mod 187. Now multiply all together. When you multiply all the terms 132 into 77 into 88, you are going to get this as 89 89443. You work out with me only so that you will be able to understand it clearly. So you will get, when you multiply all these three terms, you are going to get 894432 mod 187. Again, divide 894432 by 187. So divide this by, divide this. When you divide this, you are going to get remainder as 11. Therefore, 88 raised to 7 mod 187 is 11. Yes, the answer is 11. This is how we are going to solve the given exponentiation problems. Okay, now we'll move on to next problem. I'll give you another problem. You may ask solve as they asked to solve 88 raised to 7 mod 187, or else the question may be asked as find the least positive remainder. They will ask you least positive remainder when 2 raised to 301 is divided by 5. Yes, this is nothing. Solve 2 raised to 301 mod 5. Both are same. Yes, both questions are same. You need to find the remainder only. Understood? Don't get confused with the question they have asked. Yes, try to understand the question first. So procedure will be same. They asked you to find the remainder only. Yes, solve means you need to find remainder only. As I said before, what you need to do, you have to start with the power 1. Yes, go on solving with me only so that you will know how much you have understood. Now 2 raised to 301, what is given? 2 raised to 301 mod 5. Now, what is the rule? We need to consider base with power 1. So base is 2, 2 mod 5. 2 mod 5 is what? 2 mod 5 means what? Whenever you divide 2 by 5, because 2 is smaller, the remainder will be 2 only. Yes, how you write? You may write it as in the form of congruent. That's the remainder. 2 congruent to 2 mod 5. Yes, or as I wrote before, 2 mod 5 is equal to 2. That is the remainder. Yes. Now, our aim is to find the power 3 raised to 301. Yes. Now, as I said, you have to double this. When you double this, 2 raised to 2. 2 raised to 2 is 4. So, 2 raised to 4, 2 square. Yes, 2 square is 2 raised to 2. 2 raised to 2 is a 4. What happened then? Okay, let us do that. 2 square. Okay. 2 square mod 5. 2 square is 4. Then again 4 is smaller than 5. So, it will be remainder is 4 only. Then again double this. 2 raised to 4 mod 5. 2 raised to 4 is what? It is 16. 16 mod 5. 16 mod 5. What is the remainder? Remainder will be 1. Yes, it is 16. 5 3s are 15. Remainder is 1. Yes. Now, I have got 2, 2 raised to 2, 2 raised to 4. I want 301. Now, we'll check whether we express 301 with 4 only, multiple of 4. For that, we have to divide this 301 by 4. So, when you divide 301 by 4, what happens? 4 sevens will get 28, and this is a 21, 20. So, it is remainder is 1. Means when you multiply 4 with 75 and add 1, you will get 301. Understood what I did? I am trying to express 301 in terms of multiple of 4 and some remainder. Yes. Therefore, what you can write? Therefore, 301, the power can be written as 300 plus 1. This is what? 4 into 75 is 300 plus 1. Understood? Now, means what? We need to multiply 2 raised to 4, the power with 4 with 25. You have here in this equation. Therefore, 2 raised to 4, or you can write it as 2 raised to 301, can be written as 2 raised to 4 into 75 plus, sorry, into 2 raised to 1 plus, sorry, more 1 or mod 5. Yes. What happens now? 2 raised to 475 is what? 2 raised to 475. What is the remainder? Remainder is 1. So 2 raised to 4 mod 75, you can write it as 1 mod 5 into 2 mod 5. Understood? Now this is equal to 2 into 1, 2. So remainder is, or you can write 2 raised to 301 is congruent to 2 mod 5. So the least positive remainder is what? Least positive remainder is, you can perform in any ways. Whichever you feel easy, you perform using that method. Now, shall we check one more example? Yes. Okay. I'm going to take this power of 2 little bit higher. We'll see how you can perform. I'm going to take the same base so that it will be easy to understand you the concept. Yes. It is, find the least positive remainder of 2 raised to 1000 and it is divided by 13. Yes. As I said, find the least positive remainder, least positive remainder of 2 raised to 1000 when it is divided by 13. This is the question. So procedure will be same. First consider the power base with power 1. Go on raising the doubling the powers so that check whether you can express that power in terms of the smallest powers. Yes. Now here, since it is a base is 2, you can check. First you will get 2 raised to power 2. Yes. 2 raised to 2 is 4. Yes. 2 raised to 3 is what? It is 8. Go on increasing power. Yes. Here. Then 2 raised to 4 is what? It is 16. 2 raised to 5 is 32. And 2 raised to 6, you know, it is a 64. And so on. And it goes like this. Now, what is your m? Here m is 13. Yes, here m is 13. So when it up to this 8, 2 raised to 3, these are smaller than 13. Yes, the remainder will be these numbers only. So when it comes to 2 raised to 4, it's a 16. So when it is divided by 13, so we'll consider from that there. So 2 raised to 4, that is 16 is congruent to mod 13, means what is the remainder? When you use congruent, you have to write the remainder. Whenever 16 is divided by 13, what happens? What is the remainder? Remainder will be 3. 13 ones are. So it is 3 mod 13. Yes. If it is confusion, you create confusion, you can write 2 raised to 4 as I wrote in the previous first one. Like this. How? Like this. Write on the reminders. Yes. 2 raised to 4 mod 13 or 16 mod 13. Whatever convenient to you, write that. Yes. The remainder will be 3. Yes. And then 2 raised to 5. 2 raised to 5 is what? It is 32. So when it is 2 raised to 5, 2 raised to 5 mod 13 is what? The remainder is 32. Uh, you can take positive or negative. It is a 32. 32 mod 13. So reminder, you may take it as 2 is a 26, 3 is a 39. Yes, whichever is near. So you can write 6 or you can minus 7. Next is 2 raised to 6. 2 raised to 6 mod 13 is 64 mod 13. Whenever 64 is divided by 13, you can take, as I said, 13 fours or 13 fives. Yes. But when you did do 13 fours, the number will be higher. 5 is the remainder is minus 1. So we'll consider the smallest remainder as minus 1. Okay. Now stop to this. Now check what is your power. They are asked. They are asked it's 1000. So now check whether it is possible to express 1000 in among these powers. Yes, we can. It is possible to express 1000 in terms of these powers. So for that, we'll take consider this highest power as 6. Divide this 1000 by 6. What happens when you divide this by 6? 6 ones are yes 40, 6, 86, again 40, again 6, 36. This is a remainder 4. Now, how you can express 1000? We can express 1000 as 6 into 166 plus 4. Yes. Like this. Yes or no? Now, next we'll express 2 raised to 1000 as 2 raised to 6 into 144 plus 4. Yes. Or else you may write it as 2 raised to 6 into, sorry, it is 166. 166 166 into 2 raised to 4. Bases are same. That's why its power are added. Now we are writing splitting up the basis. 6 into 166 into 2 raised to 4. Already you know 2 raised to 6. What is 2 raised to 6 remainder is minus 1. So minus 1 raised to 166 into 2 raised to 4 remainder is 3. So now this if you want to calculate this, calculate, or else it is not necessary. Yes. Now 2 raised to 4 remainder is 3. Minus 1 raised to even power 166 is 1 only. Yes. 1 in 3. So remainder is 3. So therefore 2 raised to 1000 is congruent to 3 mod 13. Or you may tell the least remainder, and they have mentioned it is a positive is 3. This is how to calculate the required values of the remainder whenever they are asked to solve or to find the least positive remainder. You can perform like this. Yes, I hope you people now understood how to find the reminders whenever the given number is divided by some b. Yes, if you want to check these, take them as these as a homework. That is, practice them. Try to solve solve 2 raised to 50 by 7. Yes. Solve 2 raised to 23 by 47. Try these two and comment the answers. Remind us in the comment box. If you are not able to solve any of such examples, let me know the example in the comment box. In the next class, I will try to solve those examples and try to clear your doubts. In the next class, I am going to solve some other kinds of congruence examples, how to find the least remainder whenever three numbers multiply given with the three multiplied numbers divided by some other number. We are going to solve such type of examples in the next class. Stay tuned, follow my channel, subscribe for the further notification and solve the examples given for homework and answer the comment the answers in the comment box so that I can understand how much you people understanding my lectures and will clear the doubts. Thank you. Take care.